Hello everyone. Today I'm going to introduce my final project, which is about reconstructing BRDF using known BRDF databases, such as the MERL database. And the idea of this project is that the MERL database has 100 materials. And if you treat each RGB channel as a grayscale material, they will sum up to 300 materials. And because all MERL materials are isotropic, directions will be reduced to 3D in this half vector difference vector space, and which will have 1.45 million directions. And so we have a matrix of 300 by 1.45 million. For any new material, we want to find a linear combination C, which will give weights to each more material, and then we can just compute the new material as the M transpose times C. To achieve this way, we basically have two tasks. The first one is to process data and find a good space to do the reconstruction process. And then we will find the principal components using SVD. And once we have the principal components, we will solve a linear least square problems to find the best C. And the second task is to find the optimal sampling directions. And the thing is, if we have unlimited way to acquire the BRDF, we will just sample all these 1.45 or even more directions. But in reality, we need to choose the directions. And because we only have limited data, we need to choose the limited amount of direction that will give us the best reconstruction results. And this project explored two settings. The first one is directly find the best direction pairs, and the second one is to find a camera light direction pair, and then the camera take an image of the material, and we use all the samples on that image to do the reconstruction. And for the first one, directly finding the points directions, and we use condition number to select of the selected principal components. And the result is on the left, and this is the reference result. But actually, my result has a lower condition numbers. And the camera light pair one use a new error matrix, and it is impossible to run locally. And it just fills my 64 gigabyte RAM and will take at least 10 hours to run. So like for the below experiment, I just use the reference direction for the image pair. And I have explored about 3 MERL materials, and this is the first one. This is a green plastic one. This is ground truth. This is the self-generated 10 points. This is the near field photo one. And you can see that this point one is obviously darker. And this is the second material. It is a bronze material, and this is ground truth. This is the point one. This is using the reference point. And you can see the difference. You can see that choosing different points do have a big impact on the reconstruction. But it's still darker, but the reference point is still darker than the ground truth. And this is the near field photo one. And you can see there are some greenish color on the at the grazing angle. So I think both methods don't work well on this bronze case. And so I try to use more samples to reconstruct this. If I use 8,000 samples on a sample sampled from MCMC, then it will perfectly reconstruct the material. But this could because of the overfitting, because I'm reconstructing MERL based on MERL database. But we do find that if we increase the number of samples, we will probably get a better result. And this is the third material. This is the ground truth. This is the self-generated sample, and you can see it is still darker. And this is the reference direction. And it's lighter. It's brighter than the self-generated, but it's still darker than the ground truth. And this is the two near photo. This is very similar to the ground truth, but if you look at the grazing angles, there are some darker parts, but this reconstruction, it failed to reproduce these darker parts. And so I think that's all the problems I find. There would be problems at grazing angles. And for all point samples, it has a darker color. And the strangest thing is the self-generated result is always the worst one. But if I just compute the root mean square error, it is the best among all these directions. So actually, I don't know why this happens. And for these two things, I think we can find some way to work on this to make the results better. And that's all of my final project. Thank you.